Hi everyone, good morning, what's up? All good? Great. So today we will be solving the question middle of the linked list. Let's see what is this question. Given the head of a single linked list, return the middle node of the linked list. Okay, we are given with the head of the single linked list and we need to return the middle node of the linked list. Okay, if there are two middle nodes, return the second middle node. Okay, so let's see what is this thing. So 1, 2, 3, 4, 5, we have been given with this linked list which is of odd type and its middle node is 3. Okay, cool. We need to return the head of the middle node. Okay. We don't need to return the value, we need to return the complete node. Okay. And now for the second example, 1, 2, 3, 4, 5, 6. Here we can see it is of even length. So here are two middle nodes, that is 3 and 4. And here we are given with if there are two middle nodes, return the second middle node. So we will return the 4 here. Okay. So let's see how we can do it. Now we need to check for even length linked list and odd length linked list. Okay. So the very first approach which you can think of that we can simply count the number of nodes in this linked list, which is 5. Yeah. Then say first in the first iteration we can simply count the number of nodes in this linked list, and then what will be the middle of this linked list? This is 5 by 2. This is 2. And as it is an odd linked list, so we will add 1 to it. So the middle node of the linked list is 3. And then we will simply iterate our dummy pointer, or we can say we temporary pointer to the linked list and find the third node of the linked list and simply return that third node. Okay, yeah, we can do it. And now let's see for the even linked list. Here, the total number of node is 6, and here the middle node will be 6 by 2, 3. But as we have given with, if there are two middle nodes, as it is an even length string, so there will be two middle nodes. So we need to return the second node, so we will also add one here. So it will become 4. So here we need to return the fourth node. So we will simply iterate our temporary pointer to this linked list and simply return this fourth node. Yeah. So the very first approach in the interview, you will say that you will give this that we can simply iterate the linked list for counting the number of nodes, and then we will return the middle of the linked list. So what will be the time complexity of this approach? So first of all, we are doing a complete iteration for counting the total number of nodes. So it will become big O of n, and then we will iterating the half of the linked list for finding the middle node. So it will become big O of n by 2. And what will be the space complexity? As we are not using any extra space, so its space complexity will be big O of 1. Okay, cool. But this complex, its overall complexity will be big O of n. But as it is using big O of n plus n by 2, so we will try to reduce it. Let's see how we can do it. Okay. So we can reduce that complexity by the tortoise algorithm. Yeah, so let's see what is the tortoise algorithm. We will be taking as you are aware of the tortoise algorithm, that in the tortoise algorithm there are two pointers, slow and fast pointer, and we move the slow pointer by one step and fast pointer by two step. Okay, so let's see how we can apply that tortoise algorithm in this question. So we will be initializing both our slow and fast pointer with the head node. Okay, so in the next step, slow pointer will be pointing to this node, and as fast pointer is moving two steps, so fast pointer will point to this. And in the next step, slow will point here and fast will point here. Okay, so now as you can see, there is no next node for this pointer. So, and our slow pointer is pointing to our middle node. So here we got our answer. So what is the base condition for this loop? It becomes if fast of next doesn't exist, then we will break the loop because there is no next node, then how we can iterate. Okay, so now let's see for the even length history, sorry, even length linked list. So we will be initializing both the slow and fast pointer with the head node. Now in the next step, slow will become come here, fast way come here. In the next step, slow way come here, fast way go here. In the next step, slow way go here, and fast way point to null. So now if fast is pointing to null, then how we can go next? And as you can see, our slow pointer is pointing to the middle of the linked list. So here what condition becomes? If fast doesn't exist, then we need to break the loop. And if fast of next doesn't exist, then we need to break the loop. So in this way, with the help of tortoise algorithm, we can simply find the middle node of the linked list. So what will be the complexity of this approach now? So as you can see that fast pointer is iterating the whole linked list, but as it is moving two pointers in one step, so it will iterate the linked list in half of the time. So its complexity will become big of n by 2, and as we are not using any extra space, so its space complexity will become big of n. So as you can see, our time complexity with the help of this algorithm is reduced to n by 2, and earlier it was n plus n by 2. Okay, so let's see how we can code this approach. Yeah, so first of all, we will initialize the slow with the head as well as fast with the head and check if fast exists and then fast of next exists. Only then we will be iterating, and we will be moving the slow pointer by one step and fast pointer by two steps. And at the end, if we come out of this loop, we will return the slow pointer as it is pointing to our middle node of the linked list. Let's challenge this. Yeah, it's working fine. Let's try submitting this. Yeah, cool. It's working. So this was all for this question. I hope you get it. If you still have any doubts, you can surely post in the comment section. I will surely try to answer them. Till then, bye bye guys. See you soon in the next video.